Hello everyone, my name is Aman, and today, on behalf of my team, I am going to present our research regarding improvement in the world of recommendation system by using the JMSD approach on implicit feedback. Well, to get things started, why feedback is asked on almost every product application? Do most people actually rate an item or provide feedback when asked? How does recommendation engine respond when there is only a small subset of rated items? Well, the answer to above questions is simpler than you might think. There is a vast amount of information on internet nowadays. Consuming this information requires more than a lifetime. Recommender systems help users overcome dilemmas by suggesting directed desired items based on past behavior, thus saving ample amount of time. Since every system requires some data for its functioning, recommender system uses customer feedback to generate patterns among end users. Hence, customer feedback, that is ratings, become a prime factor to consider when building a recommendation system. Feedback can either be of two forms, explicit or implicit. Explicit feedback requires human interaction, like rating an item, liking or disliking an item, whereas implicit feedback observes user activity with the application, like number of orders placed, number of downloads, or number of song playbacks. In this figure, we can clearly see that user 1 and user 2 are similar to each other, but the amount of songs that user 2 has listened to are greater than user 1. So what a recommendation system will do is it will recommend your song C to user 1. As already stated, recommendation system works with both feedbacks, that is implicit and explicit. Over the past few years, intensive research has been done on explicit feedback. However, a significant amount of research is going on in implicit feedback. There are a variety of cases to handle when it comes to implicit feedback, as the user action may not be clear. A skipped song may indicate a negative rating, but it also signifies that the user does not want to listen to that song at that point of time. In the paper presented by Mr. Shah, titled Hybrid Music Recommendation System Based on Temporal Effects, he presented his observations and results using implicit feedback that utilizes cosine similarity and Pearson correlation coefficient with optimization techniques. Now, we will discuss our proposed approach and improvised algorithms that uses weighted average to increase accuracy of predicted results. So to begin with, every recommendation system requires a dataset to work with. We have used subset of million song dataset, which is the most popular song dataset. The combined mapping of songs and users is very sparse as the users listen to only a small subset of songs. Here's how our subset mapping looks like. We have songs as the columns, users as rows, and each cell represents the frequency of song listened by that user. For example, we can see that user 4 has listened to song 1 23 number of times and user 2 has listened to song 3 31 number of times. So now we have the block diagram of our research paper, which is divided into four stages. In stage 1, the process starts with collecting the data, that is structured and categorical data from million song dataset. Well, the dataset used in our research contains 10,000 songs with 70,000 users and 2 million listening history data. Now, stage 2 has four steps: data preparation, data analysis, data pre-processing, and data splitting. Further, in stage 3, what we do is we train the models using collaborative filtering techniques, namely Jaccard index and Jaccard mean square difference. Coming to stage 4, we have the evaluation of results like checking the accuracy of algorithms using root mean squared error. Now, we have been talking a lot about Jaccard index. Let me tell you what Jaccard index is. It is a statistic measure to find the amount of similarity among a pair of objects. It is defined as the ratio of intersection to union of the two objects. This is the mathematical representation of Jaccard's similarity coefficient. Next, we have mean squared difference. It is another statistic measure to find the similarity among pair of objects. The major advantage of this technique is that it considers the proportion of similarity. It is similar to Jaccard in a way, but it also gives significant weightage to the closeness of objects from the given object under consideration. This basically means that the item most similar to the item under consideration has more effect on the predicted results as compared to the item that are less similar to the same. Here is the mathematical representation of mean square difference similarity measure. Now, we have seen both Jaccard and MSD. They both have their advantages when it comes to calculating the similarity score for the given time. To have both their advantages together and take better of both worlds, JMSD comes into picture. This technique calculates the correlated items and further takes weighted average to provide a more refined similarity score. The mathematical representation of JMSD similarity measure is this. As stated in other slides, we have a subset of million song dataset. We have used matplotlib and Squarify Python libraries to have insight of the dataset. One such example is shown here. This is a tree map representation of the top 10 songs according to their listening frequencies. That sums up the dataset used and our algorithms. Our research specifically focuses on using implicit feedback and improving accuracy of predicted results. The use of JMSD would outperform existing methods since it incorporates the advantages of both techniques. Though its complexity has a lot more to go through, like scaling factors can also be enhanced to further improve recommendation systems. Let's now take a look at the results by comparing our approach to the approach discussed in the recent research papers. The RMSE error specifies difference in actual and predicted scores. We can observe the tabular summary of the results. The approach presented by Mr. Shah in his paper includes Pearson correlation coefficient and cosine similarity coefficient, which has an RMSE error of 1.84 and 1.82 respectively. On the other hand, we have Jaccard correlation coefficient and Jaccard mean square difference, which has an RMSE error of 0.95 and 0.86 respectively. It is clear from the results that our approach on implicit feedback using JMSD yields better results and hence provide more accuracy. Moving on, we have the comparison of Jaccard and JMSD technique using a bar graph. The similarity measure JMSD is compared with the reference metric Jaccard correlation coefficient as a baseline. The results are calculated over different number of nearest neighbors, and the values are plotted with their RMSE error. Clearly, JMSD performs better than the Jaccard similarity coefficient as it has less error and hence more accuracy. To conclude our presentation, let me sum it up in brief. We have evaluated two collaborative filtering approaches. Though they have their advantages, their drawbacks, such as inability to perform in sparse environments and ignoring some fractions of common ratings, leads to lower efficiency. Due to the subjective nature in music and the issues existing in the previous methods, the use of JMSD would outperform existing methods since it incorporates the advantages of both techniques. Throughout this paper, we mainly focused on implicit learning. In the future, we'll try to consider the mix of explicit and implicit learning, thus making it hybrid to make it more efficient, reliable, and focused on user-centric recommendation system. These are the references that have been used so far in our research paper and presentation. With that, I'd like to end our presentation. Thank you for your time and patience. Have a nice day. Thank you.